Dimensionality reduction, a very powerful technique in machine learning. When you are working with supervised learning problems, your input data can have many columns. For example, you might have only two input columns like IQ and CGPA, but in real-world scenarios, especially with complex problems like image or text data, you can end up with thousands of input columns. When you have such a large amount of data, several issues arise. First, handling and processing this large data becomes challenging. Second, beyond a certain point, adding more input columns may not improve your model's performance and might even degrade it. Dimensionality reduction techniques help to remove these extra columns. For instance, if you are working on a problem where you need to predict house prices based on various features, you might have columns like the number of rooms, the area of the house, and other attributes. A dimensionality reduction algorithm can combine related features into a single column. For example, it can combine number of rooms and house volume into a new feature that better represents the data, reducing the overall number of columns. This process is called feature extraction. By combining multiple columns into a single one, you simplify your data, making it easier to handle and improving your model's performance. Another important aspect of dimensionality reduction is visualization. Sometimes your data might have many dimensions, features, but you can't visualize it all in a simple 2D or 3D plot. Dimensionality reduction algorithms can reduce the number of features to 2 or 3, allowing you to plot and visualize the data more effectively.